Hello guys, welcome to LeetCode, and in today's video we will discuss LeetCode question 57 that says insert interval. So here we are given an array of not overlapping intervals where intervals of I represent start and end of the ith interval. Further, the intervals are already sorted in ascending order by start, and you are given one new interval here, and you need to insert this new interval into this original intervals such that no intervals are overlapping. Okay, and you need to return this 2D vector as our answer. Got it? So in this question, if you look at the example, then you will get better understanding. So this was our first interval, the original interval, and we need to insert this 2 and 5 here. So as you can see here, that 2 lies in the range 1 to 3 and 5 is greater than 3. So we inserted 1 to 5. So it covered 2 to 5 interval. Now the next interval begins from 6 to 9. So this is not overlapping with 1 to 5. So we have no worries. But in this situation, this is the original interval and this is the new interval. So as you can see that 4, 8 lies somewhere between 3 and 5. So you inserted 3. Now instead of 5 you have inserted 8. Okay, but as you can see 8 this 6 and 7 is overlapping with 3 and 8. Got it? Then we will update to 3, then we will move ahead. Now this 8 and 10 is also overlapping because here we had 3 and 8 and 8 is overlapping here, so we directly inserted 3 and 10, and this is the final answer. So let us take a look at some of the more test cases for better understanding. See guys, this question is more of generating different and possible test cases rather than using any logic behind the data structure. This is more oriented towards the test cases part. So here I have taken this 3 to 4 test cases and we will code according to this. So the first test case says if you have interval like this 1, 5 and the new interval is 0, 0, then this new interval will be inserted first than this original interval, because as you can see here this 0, 0 is lesser than 1, 5. Got it? So in this case we have to insert first the new interval and then the original interval. In this case we have already discussed this case, so no need to discuss that. So this is another situation that we need to handle. So this is the third situation. If you have 1, 5 and 6, 8, then you will insert 1, 5, then 6, 8, then the new interval, because the original interval is completely greater than this new interval. And if you have something like this, if there are no intervals and the new interval is 5, 7, then that is the only interval left in our result is 5, 7. So these are few of the test cases that we need to handle in the code. So now quickly move on to code and let's code this question. So here first I will make 2D vector of int and name is result. I will take some pointers, I pointers, and let me take another like n1. So let me take n1 is first the start interval of a new interval, and n2 as the end interval of the new interval. Now we will loop while I is less than n. So before that, let me also take n as the size of odd intervals. Okay, so now let us, as we discussed, we will start from this condition, right? If the new interval is lesser than the original or the ith interval. So currently the ith interval would be the first interval, as we are starting I from 0 up till I is less than n. So if n1 is less than intervals of I and 0. This is the situation if n1 means this 0 is less than the starting interval. Okay. Okay, so in this case, so let us first make another vector current. So currently so it will store the interval that we want to insert. Current dot push back. What we would do, n1, and we would also do the same thing here, n2. We would push n1 and n2. So one thing to note here is we would also make n1 point to -1. This is because this states that we have used the new interval. So here also I will do where n1 not equal to -1 and this is condition. Okay, so if this is not the case, then we have to handle the second case, where n1 not equal to -1 and n1 is greater than or equal to intervals of I and 0. So here it won't be I and 0, but it would be I and 1. Sorry, it would be n1 is less than equal to. So this is the second situation. So let's say here we have 4 as n1, and this n1 is between somewhere between this 3 and 5. That is, it is less than equal to the ending index. Okay, then in this situation what we would do, we would push back minimum of n1 and intervals of I and 0, and we would also push back maximum of I and 1. That is, let me try to explain this. So here for this situation, what we do, we have 3, 5. So here what we push, and n1 is 4, 8. So we push 3, 8. That is minimum of 4 and 3, maximum of 5 and 8. Okay. Now after this, what we would do, we would compare this 8 with others. Like we would run a while loop, and we would compare this, let's say 3, 8, and next interval is 6 and 7. See, these two are overlapping. Then what we would do, we would change to 3, 8. Again, the maximum of 8 and 7 we would take. Now the next interval is 8 and 10. Now this 8 is overlapping with this, the starting. So what we would do, we would change 3, 8 to 3, 10. This maximum of 8 and 10 we would take in the interval, current interval. And now the next interval is 12, 16. This is not overlapping with this, so we would directly push to result. Got it? And what we would do, we would also make n1 equals to -1, and we will run a while loop while current of I and 1 is greater than equal to intervals of I and 0. Okay, and also we need to increment I here also, and one condition to handle is even while I is less than n. Until I is less than n, we will loop this. We will simply change current of 1. See, it would be current of 1. Current is only of size 2, equal to maximum of current of 1, comma interval of I and 1. Got it? And we would do I plus plus, and in the end we would return the we would push back this current into the result. Now one thing to note here is, let's say we have inserted this up to 3, 10, but there is one more element, 12, 16 is remaining, one more interval, and we need to push that. So here we would write else condition. That means the m1 is not equal to -1, then only it will enter this condition. Then we would simply make current dot pushback this only, but instead of comparing, we would simply do I, 0 and I, 1. And we would increment I. So, but you might be thinking that yeah, our code is ready, but not yet. So there is a situation like this when there are no intervals here. Then we would not enter this while loop itself. So in that situation, we will directly add this new interval. That means if n1 equals to -1, that means we haven't used this new interval yet. So what we would do, we would simply push back this new interval to our result, and we would return result. Okay, now let us try to run this. Okay, oh yeah, minimum won't come, minimum maximum. It would be not equal to -1. Yeah, that means we haven't used it. Okay, so one of the test case shows wrong. Let us check that if intervals is this, the new interval is this. Okay, so here we don't have to make I plus plus because we are not using this interval I. So that's the reason we are not making I plus plus here. Okay, now let us try to submit this. Okay, so our code got accepted. Now talking about the time complexity. Say, since we are only running the loop till n, the size of the intervals, so our time complexity would be big of n, And for the space complexity, it would be also big of n because we are storing the result uh, into this 2D vector, and that would be of size n cross 2. So more generally we can say it is big of n. So that's all for this video. I hope you guys understood this question and how we would make test cases and how we would solve this question. So make sure you like this video and subscribe to our channel. Thank you.